Okay, this is going to be the fourth video in the series on how to do integration using partial fractions. And if you haven't done it yet, I would definitely watch the first few videos to catch you up to this point. Now, the difference between this video and the previous ones, and this one's we're still going to be working with linear factors in the denominator, but those previous videos had distinct linear factors or non-repeating linear factors. So this will be the first example we look at where we've got repeating linear factors in the denominator. And in this problem, we won't have to use U substitution. Sometimes you have to use it and sometimes you don't. Okay, the first step is to make sure that the degree of the denominator is less than the degree of the numerator, which it is in this case. If it wasn't, you'd have to use long division to split the problem up first. But in this case, we're good because the degree in the denominator is greater than the degree in the numerator. So the next step, just like all those other problems, is to go ahead and factor the denominator. So let's go ahead and take care of that right now. So this is going to become the integral of, and we'll go ahead and put our bar back on here. Everything will be dx. Now the numerator stays the same. So I've got x squared plus 3x minus 4. Now start to factor the denominator. Now every term here has got an x in it, so the first thing you can do is factor out an x. And when you do, that'll leave you with an x squared minus 4x plus 4. So factor an x out of the denominator. Then I think we'll scoot it over here. We'll make this be the integral of, and we'll keep going. Still be dx. The numerator stays the same. So x squared plus 3x minus 4. Then you've still got this x in the denominator. Now this, though, will factor into an x minus 2. So it'll be an x minus 2 times an x minus 2. Now I would suggest you go ahead and rewrite that. Let's rewrite it one last time here as the integral of, again, the numerator stays the same. So x squared plus 3x minus 4. And go ahead and write this as x times, and this factor is actually repeated. You've got an x minus 2 times an x minus 2, which we will write as an x minus 2 squared. And I think I'm going to put that squared in red here just to emphasize the fact that it's a repeated factor. Okay, so now we've got it factored. Now the next step is to take this rational function and break it down into partial fractions. So let's see what that's going to look like. We'll scoot things up here just a little bit. So I'll start by just, like we've done in the previous problems, let's just go ahead and rewrite this. So we'll go ahead and put our bar first, like that. Then in the numerator, it's still x squared plus 3x minus 4. And in the denominator, now we've got x times an x minus 2. And again, it is squared. And this is all going to be equal to, now again, it's just a matter of decomposing this into its partial fractions. Now, if you haven't done it yet, I would watch the very first video in this series because it describes this series of steps. I think we'll take a look at the rules that we used. So what we had was something that looked like this. How to decompose rational functions. And in that video, we went through, and if you had linear factors, you would decompose it using these steps. And I'm going to assume here that you've watched that video and are familiar with this. Now, in the previous videos, we've only had non-repeating factors, so we just had to worry about this first term right here. But in this video, for the first time, since we've got a factor that repeats twice, we're actually going to have to worry about these first two terms. So as we decompose the function, it's actually going to involve the first two terms here. So now back to our problem. And again, we'll scoot things down just a little bit here. So let's go ahead and decompose this now using partial fractions. So what this is going to be, first of all, first denominator is an x. So this first one is going to have an x in it. Then that's going to be over a. Then I've got plus. The next one, now remember, this is an x minus 2, but it repeats twice. So you're going to have to write it as an x minus 2 plus, and then a second term here, an x minus 2 squared. And then you'll put a b here, and you'll put a c here. And again, this is just decomposition using the rules that we just previously talked about. And if you're not sure about how to do that, again, watch the first video, and it will describe how to decompose it. Okay, so we've got that done. Now the next step then is to take this equation and multiply through by the least common denominator to get rid of all the denominators so we can figure out what A, B, and C are. So first of all, you've got to determine the least common denominator, and the least common denominator will actually be this part right here. So x times x minus 2 squared, and just from algebra, you should recognize that is the least common denominator of these three. So like we've done in the previous videos, multiply each term by the least common denominator. So we'll multiply this one by x times x minus 2 squared. We'll multiply this one by x times x minus 2 squared. This one by x times x minus 2 squared. And finally, this one by the same thing. So x minus 2 squared. So again, as long as you multiply each term by the same thing, you really haven't changed things at all. Now what will happen is this should allow you to have a resulting equation that doesn't have anything in the denominator. So let's see what we've got. So in this case, on this one, the x's cancel out. This x cancels out this x. X minus 2 squared cancels out this one, and it just leaves you with this. So you're going to have x squared plus 3x minus 4 is equal to, now in this one, the x's will cancel out, but you're left with a times x minus 2 squared. On this one, this x minus 2 will cancel out one of these x minus 2's, but not both of them. So this one's going to leave you with b times x times just one of the x minus 2's. And then finally on this last one, the x minus 2 squared cancels out the x minus 2 squared and just leaves you with c times x. So what you've got now is a new equation that just doesn't have any denominators at all. So we'll go ahead and put that in a box and just isolate it a little bit. So this is going to be our new equation that we're going to work with. So we'll go around like this. Okay, now just like in those previous problems, the next step is to figure out what is A, B, and C. And we're going to use the same process that you did the last time. And the idea is to pick values of x so that hopefully some of this will go to 0 and you can solve for either A, B, or C. So first of all, just looking at this, you might notice this. If I decided to let x equal 0, now what happens is I've got B is multiplied by x, C is multiplied by x, but A is not. So if I were to let x equal 0, this term will go to 0, this term will go to 0. I'll have everything in terms of x, and I can solve for A. So my first step here is going to be this. I'm going to write down to find A. So to find A, I'm going to set x equal to 0, because that will eliminate B and C. So I will let x equal 0. Now let's see what it does to this equation. So the idea is everywhere you've got an x, plug in a 0. So starting on this side, we would have 0 squared plus 3 times 0 minus 4 is equal to, here's A times, and this is going to be 0 minus 2 squared. And we'll go ahead and actually plug these things in. So this would be B times x is 0. Then I'll have 0 minus 2. Then finally plus C times 0. Now again, the reason you did that, you're trying to eliminate everything but the A. And sure enough, if you multiply anything by 0, it'll go to 0. So this entire term right here will go to 0 and disappear. Same thing with this one. This term goes to 0. And what you're left with is just what the resulting thing is here. And as a matter of fact, while we're at it, this term right here also goes to 0. 0 squared is 0, and this one goes to 0. So this whole thing turns into minus 4 is equal to A. Then 0 minus 2 is negative 2. Negative 2 squared would be 4. So that's going to give you minus 4 divided by 4. So A would be equal to a negative 1. So you've got the first letter. Okay, now you want to find the second one. So the question is, what do you go after next? B, C, and pick the one that will be the easiest to give you one of the letters. So in this first one, B had an x in it, C had an x in it, so you could set x equal to 0, and that would get rid of B and C. Now, first of all, if you decide to go after B, the problem with going after B is that C has an x and A has an x minus 2. They're not the same, so skip B at this point, and let's take a look at C. Now, if you take a look at C, the reason you might want to use this one is that if you're trying to save C and make these two, A has an x minus 2 term, B has an x minus 2 term, so if you were to let x equal 2, both of those two terms would go to 0. So in this case is skip B temporarily, and let's go after C. So we'll say to find C, this time we'll let x equal, and again, if you let x equal 2, this term would go to 0, and this term would go to 0, so a great choice would be to let x equal 2. And now just rewrite things. So again, everywhere you've got an x, plug in a 2. So this is going to become 2 squared plus 3 times 2 minus 4 is equal to A, and this is going to be 2 minus 2 squared plus B times x is 2. This one would be 2 minus 2, and then finally plus C times 2. Now again, you were hoping to get rid of some of these, and on this one, 2 minus 2 is 0, so that term's going to go to 0. This thing right here will disappear, which is what you wanted. And again, in the B part, you've got 2 minus 2. That'll turn into 0. 0 times anything is 0, so this one disappears. And the only thing you're left with is C, so now I just solve that resulting equation for C. So first of all, 2 squared is 4. Then you got 3 times 2 is 6 minus 4. Both these two terms went to 0, so you're just left with 2c. The 4's cancel out. 6 would be equal to 2c. So 6 divided by 2 is c. So 3 is equal to c. So now you've got c. So here you found A. Here you found C. Now the only question is, what is B? So you look at this thing and think about what you could plug in. The trouble is you can't plug in a number that will simultaneously get rid of C and A like you did in these previous ones. So you got to take a little bit different approach here. And that approach is to do this. At this point, you now know that A is equal to a -1, and you know that C is equal to 3. So for A, you can plug in a -1. For C, you can plug in a 3. And what that means is you can plug in any other value for X, and you'll have one equation and one unknown. Now, as far as what number to plug in, the only thing you have to be careful about, and I think we'll scoot down and put it right here. Let's put down to find, well, we'll move it down just a little bit here. And we'll say this. So we want to find B. So to find B, let X equal, and listen carefully to how to say this now, let X be anything other than the two values that you've used previously. So you can't let X equal 0 because you've already used that. You can't let X equal 2 because you've already used that. So neither one of those two values would get you anywhere. So basically, you can let X be anything other than a 0 and a 2, and you'll have an equation that you can solve for C. Now, the rule of thumb is this. Let it be the simplest thing you can get. If you wanted to, you could let it be 34. But why work with a big number when you can let it work with a smaller one? So the smallest number I can think of here would just be let X equal 1. That's the simplest number that's not either a 0 or a 2. And if you do that, and then also let A, go ahead and plug in the value for A and plug in the value for C. So let's go ahead and rewrite it one more time. So in place of X, we'll put a 1 plus 3 times 1 minus 4 is equal to, and the trick here is this. In place of A, put what A is equal to. So A is equal to a -1. And then we're going to plug in again a 1. Everywhere we've got an X, plug in a 1 squared. And then plus B is what we're solving for. So we've got B times, and again, everywhere we've got an X, we'll plug in a 1. So we'll plug in a 1 there and a 1 there. That takes care of that part. And then finally, plus, and in place of c, put what c is equal to, which would be 3, and again, in place of x, we'll put a 1. So what this gives you is a single equation that has one unknown. So we'll go ahead and solve this. So this is going to be 1 plus 3 minus 4 is equal to, and here is a minus 1. And what this would be, 1 minus 2 would be a negative 1, squared would turn back into a positive 1. Then you've got, this would be 1 minus 2 would be a negative 1, times 1 would be a negative 1, so this will actually turn into a negative b. And then finally, this is just going to be a 3. So it looks like that. Now over here, you've got 4 minus 4. This was going to go to 0, is equal to negative 1 minus b plus 3. And we'll move the b over to this side. And you'd have negative 1 plus 3, which would be equal to a 2. And so now you've got b. What you've got now is all three of your things. A is negative 1, C is 3, B is 2. But you had to use a little bit of a different logic on that one. So to go back up a little bit, we'll move back up to here. And again, A is negative 1, B is 3, and C is 2. So that means up here, and I think I'll put them in blue. A was a negative 1, B was 2, and C was 3. So we can rewrite the integral in terms of just this right here. So that's what we'll do in this next step. So we'll move back down, get a little room, and let's go ahead and rewrite this as following. We'll make it be the original integral, which was, I think I'll move it down even a little bit more. So the original integral dx, and we'll go ahead and put it in its factored form. So the original problem was an x squared plus 3x minus 4, and we factored it into an x times an x minus 2 squared. And we just showed that this is going to be equal to the integral of, now the first one, again, I'm looking at just this factored form right here. So it's going to be minus 1 over x, 2 over x minus 2 plus 3 over x minus 3 squared. So you're just going to rewrite it in that form. So this would be minus 1 over, and that first term was x. This will be dx. We'll split it up into 3 separate integrals, plus the integral from, and b was 2, and this was over x minus 2 dx. And then finally plus c was 3, so this would be the integral of 3, and the denominator here was x minus 2 squared dx. So what you've done is changed it from a complicated problem into 3 fairly simple integrals. Now at this point, you actually do need a rule for this, so let's take a quick look and just to remind you what the rules are. I think I'll do this. I'll factor the constants out first. So let's make this be minus 1 times the integral of 1 over x dx. Then here you can factor out a 2. So this will be 2 times the integral of 1 over x minus 2 dx. And then finally, this one's going to be plus 3. And this would be the integral of 1 over x minus 2 squared dx. So let's move things down just a little bit here. Now what we've got when you get ready to do this is a rule. This is going to be 1 over the, and the question is, what do these simple integrals fall into? And it'll actually be this part right here. We'll go ahead and scoot this little rule up. The first two will actually fall into this rule. The integral of 1 over u du is equal to the natural log of the absolute value of u. And that's going to apply to this first integral and this second integral, but this third integral will actually just be the power rule. So let's run through these and see what we've got. So on this first one, it's going to be, here's a negative 1, and again, this is just a simple x, so you don't need to use substitution, so that will turn into, using this rule right here, natural log of the absolute value. So this would be the natural log of the absolute value of x, and again, there'd be a plus c here, but we'll save that and combine all the constants at the end. Then this one is going to be, here is 2 And again, as long as this is just a simple x, then you don't need to use u substitution. And this will turn into the natural log of x minus 2. That's something we've discussed in a previous video. Now this one, though, is going to be a little different. Let's go ahead and we'll rewrite this like this. This would be the integral of, and I'm going to rewrite this as x minus 2 to the negative 2 dx. And here you can just use the power rule. So we'll let this be equal to negative 1 times the natural log of x plus, and this one was, again, 2 times the natural log of x minus 2. And finally, this one is going to become 3. And again, you can apply the power rule. Now, if you wanted to, you could do u substitution and let u be equal to x minus 2. But you'll find, as long as that's a simple x, you really don't need u substitution there. Just apply the power rule. So that's going to be equal to, now it's going to be x minus 2 to the negative 1 power divided by a negative 1. And then at the end of the whole thing, we'll have a plus c. Okay, so we'll rewrite things a couple more times just to rearrange it and put them in a final form. This one stays the same. So minus 1 times the natural log of x plus 2 times the natural log of x minus 2. And then let's take this negative 1, move it out in front. So this becomes a negative 3. And then finally, let's do this. Here's an x minus 2 to the negative 1 power. Let's move it to the bottom, make it be an x minus 2 to the positive 1 power, and then plus c, and finally u will have it. So again, split it up into 3 intervals. Now let's back up to the top and take a quick look and just kind of review through the whole thing. So the first step is to factor the denominator, and you get it in its most basic form. Then decompose it using your rules of decomposition. And again, just real quickly, let's go back to just remind you, if you're not sure about how to decompose the thing, go ahead and watch the first video, and it explains how to run through decomposition, how to get this part right here. Okay, then once you've got it in this form, multiply through by the least common denominator, which will remove the denominator from all these and leave you with this basic equation in the red box. Then, to solve this equation, is go after whichever letter you think is easiest. And the idea is to pick a value of x that will eliminate the other 2 variables. Well, when you went after a, letting x equal 0 eliminated b and c. Then, to go after c, they both had, a and b both had an x minus 2 term, so you let x equals 2. And then finally, the last one's a little bit different, is you had to use a value of x plus the previous values of a and c to determine that final letter b. Anyway, once you got the 3 values, then you could rewrite the integral, and you could rewrite the integral like this. This was a, this was b, this was c. And it's just a matter of doing each one of these 3 remaining integrals. And when you do the 3 remaining integrals, you came up with this. And it was all based on, just a reminder, this rule for the integral of 1 over u is equal to the natural log of u. So what that is, that's an example of a problem, and again, we'll scoot back up here one more time, at the top where you had, right here, a repeated linear factor. So it changes the way you go about things just a little bit. And in the next video, we'll look at, for the first time, quadratic factors. So far, everything we've done has involved linear factors. So quadratic factors in the next video.